Hello guys, today we will see the Leetcode problem number 190, which is reverse bits. So in this question, it is a very simple straightforward question. So here reverse bits of a given 32-bit signed integer. So what we have to do in this question, that we have to reverse all the bits, means we have this number of bits, okay, this all bits we have to reverse all of them, okay. The 32 bits are present there, so we have to reverse all the bits. Means if we have, okay, let's consider this, if we have 1 1 0 1 0 0 0 0 0, so it must be up to 32, okay, and all of them we have to reverse, okay. So how we can reverse? So this one will be at the 32th position, okay. So this will be at the 32th position, 32th. So this one will be at the 32th position, and after that we have at the 31st position we have this 0, and after that 0 1 1, and then all the zeros will be up to the 0th position, okay. And in this way we have to reverse them, okay, all the bits. So how we will do this? So for doing this, we will make another answer integer, which will be, we will be initialize it with the zeros, okay. Now from now we will go from this, we can go travel from left to right or right to left, okay, whenever we want, okay. Then this when we traverse from the 0th base indexing, okay, 0th means one left shift of the zeros, which results into this this integer, okay. And this position represented by the one left shift of the zeros, this position will represented by the one left shift of the 1, okay. And in this way, when we traverse bitwise, so it will represent the right to left flow, okay, right to left traversing, we can say. Then when we are traversing from right to left, so for reversing this we can traverse for answer as right, left to right, okay. So in this way, if we traverse from, okay, the nums which are given to us, n value which is given to us, we will traverse from right to left, and for answer we traverse from left to right. So in this way our answer will be already in the reverse format, okay. So how we will now explore this, that when we are traversing from right to left in our n, okay, when we are traversing from right to left, then we will check that if it is a set bit or not bit. So how we will check if that bit is a set or not? So if there is a bit set count, that if one left shift of ith, okay, if that particular bit is set bit or not, so we can make it, we can apply the AND operation here, and if that set bit is a set, so it will return it as a 1. And if it is not set bit, means we have the AND operation at 1 and 0 we have 1, and 1 and 1 we have 1. So sorry, 1 and 1 we have 1, and 1 and 0, sorry, 1 and 1 we have 1, and 1 and 0 we have 0, okay. So in this way, by using the bitwise operations, we can check if that particular bit is a set bit or not. So if that bit is a set bit, so if this condition validates, okay, if this if loop runs, so then we will traverse from left to right in the answer. So in answer we will store it as a answer XOR equal to the one left shift of the 31 minus of ith. So this 31 minus of ith means, because there are 32 set bits, okay, 32 bits are present there, So if we count for zeroth bit, for zeroth bit of answer, for the n, zeroth bit of n, and if we count for 31 minus of I, means initially we have 0, I as a 0, so it will represent the bit 31th bit of answer, 31th bit of answer. Because if we talk about the 32 bit, so we have there only 31 bits. Okay, if we talk about 64 bits, so we have only 63 bits are present there. Okay, we cannot try for the 64th bit. Okay, so in this way, when we talk about any of the bits, if we talk about 128 bit, so there is only 127 bits up to which we can go. Okay, in the bit set. Okay, so that's why when we have to reverse all the bits, so we can XOR one left shift of 31 minus of ith, means 31 minus of ith will be 31th bit, not the 31th bit, it will be the 31th bit, not, it will be the 30th bit. Okay, so in this way we will approach this question. Let's see what the solution is. Okay, we are initializing the answer as a 0 and we are traversing from 0th to 31th bit. Okay, so if we try for the I left shift of the 31th, so we already are at the 32th bit. Okay, because this zeros because this one is already present on the 0th bit, 0th bit, not 1th bit. Okay, so if 1th is already present at the 1th bit, so we are left shift, we are doing the left shift of the 1 31 times. If we okay, let's see, if we left shift 1 2 times, so what we will make, as 1 is presently here. Okay, then 1 is currently now 1 is at the first position, then second, third, fourth, these are the positions. Okay, we have, these are the positions we have. Then initially when the 1 is at the 1th position, then after left shifting doing the left shift for the 1, so we have 1 here. Okay, so 1 is at the now 2th position. Then when we left shift 2, okay, 2 times, so 1 will be at initially here, so after doing left shift 2 times, so 1 will be at the 3rd position. So in this way you can see that 1 left shift 2 times, so it will come at the 3rd position. So when we left shift 31 times, so it will come at the 32th position. So in this way we can get the 32th bit. Okay, so in this way we are traversing this. Okay, so initializing we temp means contains the 1th bit, or we can say the 32th bit of the means 1 left shift of the temp now. So when we are initializing answer, so we have 0 0 0 0, and when we have n as there, so 0 0 0 1 1 0. Okay, in this way we have 1 0 1. Okay, in this way we can have 1 1 0. Okay, now this bit should go in this bit, so this bit is the 32th bit. Okay, so that's why we are representing 31 minus of I. Okay, and when okay, I will rough it all. Okay, erase it all. Okay, now when we have this 1th bit as a set bit, so in this if condition it is checking that if this 1th bit is a set bit, so the answer will be changed as a XOR. So it will come as a XOR, means bit for the XOR if we have 1 XOR 0, so we have 1. If we have 1 XOR if we have 0 XOR 1, 0 XOR 1, so we have already 1. If we have 1 XOR 1, so we have 0. Okay, in this way we have, if both of them are equal, so yeah, okay, again we have, again one condition is there, 1 0 XOR 0, so we have 0. Okay, so there for making it as a set bit, so we can we have to take that one of them as a 1. Okay, and if we haven't checked this condition, so then also our that condition will be valid. Okay, because when we check this condition, so it will return 0 or 1. So if it is a set bit, so we can XOR it directly. Okay, 1 XOR 0, 1 XOR 0 will results into 1. If we XOR 0 XOR 0, so it will return into 0. So along with this, we can do one of the thing to make it more simplifiable. Let's try it out, that yes, this without making if condition, you can make it XOR with this. Okay, without making XOR with this and this. Okay, this and this. Okay, so you can make like the XOR with this only. Okay, you can consider this as a XOR. Okay, but that number should be the XOR. Okay, that number should be the XOR, so that's why yes, you have to do this. Okay, you have to check this this condition. Okay, firstly you will have to check that condition. Then after that, after checking that condition, if this is the set bit, so you can make this bit as a set bit. How? Let's see how we can do this. That answer XOR 1. So yes, in this way, if you submit this question, so you will get the perfect answer. Okay, yes, this is the 100% optimized solution. And if you have any of the doubt, please comment it below, and I will see you in the next video. Thank you.